Hello, students. You're welcome today. Today we want to have a very good topic: indices. Okay. Now, when we talk about indices, indices is coined from a root word, which is index. Okay. Index. What do I mean by index? Now, index is a real number. Okay. You can say a number is written in an index form if that number is a real number written in the form of a raised to power x. Any real number written in the form of a raised to power x, where x is the power or the exponent, then while a is the what? Is the base. Okay, it says to have been written in index form. So the in index form, when I say in index, index means one or singular. Okay, then while indices means the plural form of index is indices. So today we are going to work on indices. Okay, now let's start that by working on the laws. We need to understand the laws of indices. Now, when we talk about the laws of indices, now we start with the most popular one, the multiplication law. Now, in multiplication law, it says that if two numbers of the same base, if two real numbers of the same base multiply themselves, the power will be what? Added. That is the law of multiplication. Meaning, if I have a raised to power 2, okay, let me say a raised to power x multiplied by b a raised to power y. So what does that mean is a raised to power x plus y. Okay, now let's use a number. If I have 10 raised to power 3 multiplied by 10 raised to power 2, this will give us 10. Don't say 10 times 10, please. Just pick one, and since they are of same base, 10 raised to power 3 plus 2 is what? 5. Okay, so that is just how it works. Then number 2, this number 1. Number 2 is division law. Division law. Now, in division law, what do we need to know? Now, if two numbers of the same base divide, their powers will do what? Will be subtracted. For instance, I have a raised to power x divided by a raised to power y. So what do I get? I will have a raised to power x minus y. That is to say, 10 raised to power 3 divided by 10 or raised to power 2 will be same as 10 raised to power 3 minus 2, which is 10 raised to power 1, which is what? 1. Otherwise, in other words, you can say 10 raised to power 3 is 10 times 10 times 10. Okay? Then divided means over. 10 raised to power 2 is 10 times 10. Then when this 10 cancel 10, this 10 cancel 10, what remains? 10. Okay? So you can apply this way. If you don't want to work with this method, you can work with this method. You can still get the same thing. Now, number 3 law is zero power law. Zero power law. Now, what do I mean by zero power law? That is, any number raised to the power of 0, any real number raised to the power of 0 is what? Is 1. Provided the real number is not equal to 0. For instance, let me take for instance, a raised to power 0 is what? 1. If and only if a is not equal to 0. A should not be 0 because 0 raised to power 0. Okay, so we are looking at 0 raised to power 0. 0 is a real number, but we don't want a to be 0. Okay, so now that's it. Now we have, let me say, b, 5 raised to power 0 is equals to 1. 10 raised to power 0 is also equal to 1. So any number raised to the power of 0 will be 1. Okay, that's that. We work on number 4. Number 4, let's talk about negative power law. Negative power law. Okay. In negative power law, we're going to have if a raised to power minus 2. What is a raised to power minus 2? A raised to power minus x would be Since it's minus, so please take that minus to this way and write 1 on top of it. Then this become x. Sorry, our a. Then that a will have the power here. Okay. So meaning if a number, any real number is raised to power negative value, so you take the inverse of that number. Take the inverse of that number. Okay. Take the reciprocal of that number. Now, what that means is if I have 10 raised to power minus 2, what will that be? It will be 1, okay, over 10 raised to power 2, which is same thing as 1 over 100. Okay, so that's it. That is how it works. So we'll soon apply it. Number 5 law is power law. We can call it power law. So in power law, if I have a raised to power x, then raised to power y. So what would that be? A raised to power x raised to power y, or bracket, the power is of this. So what will it be? It will be a raised to power x, y times x, not y times a, with xy. Okay. Now, like if I have 5 raised to power 3, then in that we have 2. It will be 5 raised to power 3 times 2 is what? 6. Okay. So that is power law. Now let's go talk about 6. Distributive power law. Distributive power law. Now, how do we have distributive power law? If I have a raised to power x, okay, then okay, or ab raised to power x. So if I have ab raised to power x, remember this bracket is governing both a and b. So it will be a raised to power x, then b raised to power x. Okay, that's just you've distributed it. Okay. Now, what if I have a b raised to power over xy raised to power x? Okay, that will give us a raised to power x, b raised to power x over x raised to power x and y raised to power x. Please make sure you distribute up and down, except on the contrary, if it is ab over xy, then it is only here that is raised to power maybe 2. Okay, please, this will just be only with respect to the numerator, because the bracket did not cover to the denominator. So we are going to have it as a raised to power 2, b raised to power 2 over x and what? Y. Okay. So this now, of course, this is not the same. This is not the same with this. This is not the same with this. Okay. So that's it on distributive power law. If I have, let me take another example or another law. We've done to 6. This is law number 6. Okay, let us talk about law number 7. Please pay attention on this law. Now, we are going to talk about root power law. Okay. Now, in root power law, if a number is raised to the power of a fraction, remember, it's not a fractional power law, but the power is in the form of x and x over y. So supposing I have a raised to power x over y. Okay. Now, if any number or real number is raised to the power of a number the power of that is in the form of x over y, where y must not be equals to 0 now, of course. Where y is not equal to 0, that is number 1 condition. And number 2 condition is y is equal to 2. That is the 2 condition. One is y must not be 0, but y is 2. And the same y must not also be equals to 1. Because if y becomes 1, then x will automatically turn to what? A whole number. So y will not be 0, y will not be 1. Okay? Now, but y is to be 2. And y must not be greater than 2. Y should not be greater than 2. Okay? It shouldn't be greater than 2. It cannot. If y is greater than 2, then it will no more be root power law. So what do I mean by that? If I have a raised to power x over y, remember this is the condition. Y must be 2, which means it becomes the the square root so that it becomes the square root of a raised to power x. Let's take, for instance, I have maybe 5 raised to power 1 over 2. So what will this be? This will give us square root, okay, of 5 raised to power 1. If I have 8 raised to power 1 over 2, what will it give us? Or 3 over 2. It will be square root of 8 raised to power 3. Then if I have 16 raised to power 5 over 2, it will be square root of 16 raised to power 5. Okay, so what did you observe here? The denominator here is 2, the denominator here is 2, the denominator here is 2. And that's why they are taking the square root form. And it will be bad, please, let me just say this. It will be bad to put 2 here, please. If you do that, that is bad. Very, 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 very bad. So don't try to put a 2 there. Allow it that way. That square root has covered it too. Remember, when you have a raised to power 2 is equals to 9. How do we do it? You bring square roots. Okay? You ask square root, you bring the square root to the both sides, which is square root of a raised to power 2 is equals to square root of 9. Why do you bring square root? Because square root can cancel square. Okay? So this square will cancel square root. Our a now becomes square root of 9 is 3. Okay? That's why you don't need again to put 2 here. Okay, now having done this, we go to the last one. So if I have a raised to power 3 over 2 will give us square root of a raised to power 3. Now the last one, 8, is fractional power law. Okay, now in fractional power law, please pay attention. I will be very happy, very glad if you will understand it to the point of differentiating between fractional power law and root power law. Many students get it mixed up. Okay, now in fractional power law, if any real number is raised to the power of a fraction whose denominator, okay, the power of that fraction, the denominator is greater than 2. Take it. It must not be 0, it must not be 1, it must not be 2. If it is 2, you are wrong. It will not be from 3 above. So if I have a raised to the power of x over y, I use the same thing. Here, this implies that y must not be equals to 0, y must not be equals to 2, okay? Y must not be equals to 1, obviously. But y should be greater than what? 2. Which means, it is strictly greater than 2, meaning that y can be 3, can be 4, can be 5, can be 6, can be anything. So why do you need it that way? So that you take that root of that. For instance, if I have this now, the simplification of evaluation of this will be white root of a raised to power x. Now, if I have a raised to power x over n, it becomes nth root of what? A raised to power x. Okay, let's take number example. If I have 8 raised to power 1 over 3. What did you observe now? Check the other examples I was using in terms of root power law. You see that the denominator were always 2. But now the denominator should not be 2. What this give us is cube root of 8 raised to power 1, which is cube root of 8. And cube root of 8 is what? 2, which is 2 times 2 times 2, which is 2 raised to power 1, and its answer is 2. What if I have as 27 raised to power 2 over 3? Here, I'm going to have it as 27 raised to the power of, cube root of 27 raised to power 2. And cube root of 27 is what? 3. And that will give us 3 raised to power 2, which is equals to 9. Okay, so this is exactly what we are talking about. Now, you have been able to differentiate. Remember, okay, it will not be only 3. In case if you have something like 32 raised to the power of 2 over 5. Something like this. Please, it must not be 3. Of course, I have defined it here. It should be strictly greater than 2. So any number can work. So let's assume I have 32 raised to power 2 over 5 will give us fifth root of 32 raised to power 2. And what is fifth root of 32? That is 2. Because 2 raised to power 5 is 32. So I'm going to have it as 2. Then the power here is 2. So 2 raised to power 2 is 4. Okay. So this is where we stop it so that the video will not be too long. Please, in case you don't understand anything, ask your question at the comment section. I must come in. So our next video will be working on application of these questions. Okay. How do we apply it in solving problems? Thank you. Please do well to subscribe, share, and like this video. Thank you.